Welcome back. So, today we are going to talk about the climate change and its relation with the Earth place in Earth's place in time in space. Okay. Now, there are many hypotheses, and to some extent we have been talking about that the climate change is taking place and all that, and that is because of the anthropogenic activity. There are still the arguments that whether the influence caused by the anthropogenic activity or the humans are really driving the change in the climate, or it is just a matter of global warming. Because the climate change, as you will see in this lecture, we will try to look at some examples that the climate change is certain, but it takes time, and it is related to the revolution, or we can say the rotation of the Earth around the Sun. So, let us go ahead and see more in detail. So, climate change and its relation with Earth's place in space. So, the environmental effect of Earth rotation in total, if we take, then it is what we see is rhythms of sun causes, one, day and night, because this is the Earth is revolving around the sun, and then we have this the day and night. We have daily air temperature cycle, because not the always the in daytime the air temperature is different, and night the air temperature is different. Then motion of atmosphere and ocean, this also we see because of the rotation of the Earth. Weathering systems and ocean currents, and then Earth rotation plus moon gravitational pull causes the fall and rise of the ocean, that is resulting into the tides. And then tidal currents, life giving pulses for plants and animals, clock for human, coastal activities, etc. So, these are all effects of the rotation of the Earth. Further, the circle around the Sun by an Earth, it is around, that circle is 356 days. Earth completes its own one full resolution around the Sun in 365.25 days, and that is how the month of Feb has been calculated. That is half one day off in some years. And then revolution, it completes in 365 days, that the first complete, and from North Pole in counterclockwise direction. So, the revolution is from North Pole in counterclockwise direction, it is not in clockwise one, and the orbit which is take around, in which it rotates, it is elliptical, it is not complete circle, and it is not the same distance it has from the Sun when it is passing through an opposite areas. Some places it is nearer to the Sun, and some away from the Sun, and this away and near distance is responsible for giving us different seasons. So, the distance of the Earth from the Sun varies during the year, and this variation in the distance gives us different seasons. So, this is how it has been shown in this diagram. It shows that at this location, that is on Jan 3rd, the distance of the Earth is closer to the Sun, whereas in July 4th the distance is much larger as compared to that of Jan 3rd. So, the closer to the Sun when the Earth comes, while it is having its journey through this elliptical path that is known as Perihelion, and the largest distance is known as Aphelion. And then in some locations along the orbital path, it come across the equinox, that is what we will be discussing, where the whole earth will have the equal, and the earth will be divided in the half in terms of the sunlight received and the solstice. So this we will learn in coming slides. So the distance never remains the same, it varies along the elliptical path, and then what we have learned that it rotates in an elliptical along the elliptical path from north in anti-clockwise direction. So the distance when the earth is nearest to the sun is called Perihelion, which occurs on or near Jan 3rd every year, whereas the farthest distance away from the sun at Aphelion, it occurs nearly around July 4th. So this is the distance which is given, that is a distance at the time of the Perihelion and at the time of Aphelion. What will be the distance from the sun? So the four season, as I was talking about, this is the reason, one of the reason that the radiation which has been going right, or the sunlight which has been put on the earth's surface, is not the same, it will vary. So we get different seasons like summer, winter, spring and autumn. So the four seasons occur because the earth maintains a constant orientation, and that is a tilt. The tilt is with respect to the vertical, the tilt is along which it rotates, axis is around 23.5 degrees, and that is with respect to the perpendicular to the plane of the elliptical. So elliptical plane, perpendicular to elliptical plane, it has an inclination of 23.5 degrees. Solar illuminations with respect to earth. So at different time, the earth has different radiation which has been received, or the sunlight. So what we have seen, as we were talking about the Perihelion and Aphelion, where the distance of the sun with respect to the earth is different. So in one case it is closer, in one case it is away, and that also affects or play the important role in having the seasons. Now equinox, at the equinox that happens every March and September every year, the earth axis of rotation is almost right angle to the direction of the solar illumination, and this divides the day and night, dividing the globe in half, with solar circle passing through the north and south poles. So the north and south pole, through that solar circle, where this depending on the, it depends on the earth, it depends on basically the solar illumination which is falling on the earth's surface. So it divides exactly into the half, and time duration of day and night are same around the globe. So we also learn in day-to-day life and the seasons that today's day was longer or night was longer, and the days are becoming shorter and the nights are becoming longer. But here during the equinox, the whole globe has been divided in half based on the solar illumination received by the earth. and this division is through the solar circle, that is what we are talking about, north and south pole, and it divides the earth in half, and also the time duration of the day and night is exactly the same. So this is how the earth will be seen if you are in equinox. An equinox is taking place when the earth is at this location, and that is what we say it is divided into exactly half. So the illumination is almost perpendicular to the earth's surface. That is, the earth axis of rotation is right angle, so it is almost right angle to the earth axis of rotation. And this is an example of solstice, where it is not the same, but one portion of the, that is the north pole, will have either, this again occur in June and December. So in June and December, it is not in exactly right angle with respect to the inclined axis of the earth. So in this case, we'll have 24 hours a day, so full day and full night will be experienced at the North Pole, and the time, that is the day hours and the night hours, will vary at different places. So solstice is basically it will result into the complete full day and full night at the equator, not equator, it is North Pole. Now these are very important parameters, that is eccentricity, obliquity and precision, which usually controls the climatic pattern. And this was a theory which was been given by Milankovitch, that is global climate change. And these changes are certain. These changes will take place when there is some alteration in either eccentricity, obliquity and precision. Now let's see what do you mean by obliquity, eccentricity and precision. So during 1920, an Yugoslavian astronomer proposed that the Earth's climate change is cyclic and mainly depends on variation in three parameters of Earth's orbit, and these three parameters are eccentricity, obliquity and precision. So eccentricity is basically the shape of the Earth's orbit, either it is ellipse or circular. So right now it is ellipse, but it can go into and have circular orbit. So this is basically the eccentricity. Now you can judge what we were talking in the previous slides, that if it becomes circular, then what will be the climatic conditions, or we can say the seasons which we will experience on the Earth's surface. Then comes the obliquity. Obliquity is basically the tilt of the Earth's axis. So the tilt of the Earth axis right now, what we have, you see, is 23.5. It varies, it will change, and the change will take place in this fashion. So it will change here and it becomes low, or it becomes high and go up to 23.5 degrees. And then third is your precision. Precision is basically the change in the direction of the Earth axis. So right now what we see is that the Earth axis is facing the North Star, it may change to the other one. Okay. So, the change in the direction of the Earth axis over the time. So, these are the three very important parameters which will result into the change in the climate, global climate pattern. So, he suggested that he attributed the onset of ice age during Pleistocene epoch due to variation in the following three parameters of the Earth's orbit. So, as we were talking and discussing in the beginning, that the Pleistocene epoch faced a lot of climate change, and even the Holocene we are experiencing the global warming. So, this obliquity, eccentricity and precision, if there is change in this, then we will experience the change in the climate. So, when eccentricity is 0, then the orbit is circular, but when the eccentricity of the Earth's orbit to its maximum of about 0.0607 takes a cycle of almost 1 lakh years. So, this will take 1 lakh years. At the present, what we have is the eccentricity is 0.017. So, the change in eccentricity will affect the position of Earth with respect to Sun, and that is how it will be affected, because what we are absorbing, or the radiation which is coming from the Sun or the sunlight falling on the Earth's surface, that will vary if the eccentricity changes, because if it becomes circular, then the climate or the seasons, we will have very much similar seasons in all countries or throughout the globe. We will have similar conditions of the climate. And as we were talking about the equinox and solstice, so that also will vary if the eccentricity changes. So, the change in the eccentricity will affect the position of Earth with respect to Sun. This will change the distance of Aphelion and Perihelion. So, the farther distance and the shortest distance will change, which in total will affect the climate plus seasons. So, this is extremely important in terms of that. So, the overall climate will be affected because of the change in the eccentricity. So, this one has to keep in mind. So, this was the part of the eccentricity. Now, coming to the obliquity. Obliquity or change in the tilt angle of the Earth axis is the second parameter of the Milankovitch cycle. So, inclination of the Earth axis with respect to its plane of orbit around the Sun, this is the inclination. So, this will change. So, the oscillation basically in the degree of Earth's axial tilt occur in the period of 41,000 years, and which varies from 21.5 to 24.5 degrees. Right now we are having 23.5 degrees. So, when it reaches to 24.5 degrees, the climate definitely will change, because the radiation which has been received by the Sun, from the Sun by the Earth, will vary. So, this is another parameter which will affect the climatic conditions on the Earth. Third one is, so this is the axial tilt which has been shown, which takes almost like 41,000 years, and the first one was eccentricity, it takes 1 lakh years. Then comes the precision. So, the rotation, Earth's rotation around the Sun like spinning top. So, wobbles take about 26,000 years to complete the cycle. So, cycle will be taken as shown here. So, it takes 26,000 years to complete the one full wobble. So, now the axis is pointing towards polars, that is north star, Polaris. So, that is the north star, and about 13,000 years, that is after 13,000 years, the axis will be pointing towards the Vega. So, this will change the direction of the axis. So, it will keep on rotating on the same axis, but the wobble will result into the change in the position of the axis. Right now, it is pointing towards north star, but it will after 13,000 years it will point towards the Vega. So, definitely there will be a climate change. So, precession is caused by the gravitational effect of sun and moon. So, the change in position of axis will causes the shift of position of equinox and solstice around the Earth's orbit. So, again this is going to affect the solar radiation we are going to receive from sun. So, this will again affect the equinox and solstice. This change in the timing of the equinox and the solstice will change, as well as the Aphelion and Perihelion will change, and the overall effect will be the change in the climate. So, this is what has been shown right now. The orientation is towards the Polaris, and the time will come, it will change towards the. So, this takes almost, how much we said, 26,000 years. Okay. So, one is 1 lakh, that is eccentricity, then we have 41,000, and then we have 26,000. Therefore, the change in the position of Earth with respect to sun, the climate and seasons will differ, or we will be having different climate as well as season. It will. So, continuous change of these 3 parameters will affect the amount of solar heat received at any latitude, which will vary over the time. These changes are responsible for the mechanism of glacial and interglacial episodes. So, this is the part of the precession. So, we will stop here and we will continue in the next lecture.